Now let's start the naming now. So what is the name of this structure here? So to name this, remember I told you that one carbon is met, two carbons is earth from first video. Go and watch the video again. Now three carbons is prop, four carbons is both, like that. Now let me take this as rule number one. Before you can name any organic compound here, then you have to locate the longest carbon chain. So that is the longest continuous carbon chain. So that should be the rule number one, because it's that number of carbons that will determine whether it's met, earth, both, prop, or like that. So now see the rule one now. Count the longest continuous carbon chain. So in this case, you will see we have numbered 1, the carbons 1, 2, 3, 4 forward. Also number it backward 1, 2, 3, 4. In both cases, it is 4 that is the longest continuous carbon chain. You know this is a chain, as in the longest carbon chain. In another question, you will see how we can derive different chain. So for this one, we have 4 carbons. And remember, 4 carbons is both. Now everything is single bond. And remember, it is alkanes that have single bonds. So that means for all these ones to have single bond, then we have surface. The surface for alkane is ANE. So this is the usefulness of that table I drew the other time. So that is, we have prefix and suffix. So suffix will come after. So that means this is the butane, because 4 carbons is both. Then single bond is alkane and the suffix is ANE. So you just add the suffix there. That is butane. That means this structure is butane. So as you can see. So now let's see another one. So this one now is butane. So let's see another structure. So take this as rule 1. Count the longest continuous carbon chain. Is the one that will determine whether it's earth, met, both, prop, x, oct, like that. So single bond, double bond, triple bond will now determine maybe it's in that you will add to all those mets, like that. Just like I added ANE to both to be butane. Both is 4 carbons, ANE is for alkane, so it's together. So now let's see another question. Let's say you want to name something like this. And as we are drawing, you count the number of bonds, because the number of bonds must tally. The number of bonds must tally. Look at this now. This is carbon. So I have 2 bonds here, 3, 4. It's correct because carbons must have 4 bonds. This is 2 again, 3, 4. It's also correct. Carbon must have 4 bonds. 1, 2, 3, 4. Correct. 1, 2, 3, 4. Correct. And each hydrogen have 1 bonds. Is also correct. So that means this structure is correct. How can we name this structure now? Remember, I said you name forward and backward. So now, if you name forward, this will be 1, 2, 3, 4. Name backward. Also, this is 1, 2, 3, 4. So now, this double bond is closer to which number? Because this bond, we must state the position of this bond. So now it's closer to which number? If you say it's after first carbon here, if you count this way, that is 1, 2, 3, 4. That double bond is after first carbon here. But if you count backward, 1, 2, 3, 4 is after the third carbon. So I will pick the one that is very close to the carbon, that is after the first carbon. Now let's name this. So we have number forward and backward. So what is the longest carbon chain here? So the longest carbon continuous chain here is 4. That is 1, 2, 3, 4. Even backward is 4. And 4 is both. Now you will notice you have double bond here. So that means the double bond is in the surface. So that is ANE. That is alkenes. So the surface is ENE rather, because it's alkenes. So it's ENE. So that is what we will add there, ENE, because we have double bond. So that is alkenes. So that means the name of this structure is butene. So this is butene. Now if you want to specify the position of the in, this is like saying but one in, because the double bond is after the first carbon. So this is but one in, that is after the first carbon. But instead of writing but one in, one is invisible, so it's better you write butene. So the name of this structure is butene, like that. So let's say another one. Let's say we have something like this, H. So let me put CH3 here. So this CH3 here is an attachment, and if you don't take it as attachment, you can still split it. So let me split it because I will explain the two. So this CH3, let me split it. So it can also be like this, 4. So that's CH3, meaning I have C here, then 3H, as in that CH3 is here. So this CH3, I can expand it that way. So I want you to see something there. Even though I did not expand, it's still the same. But no, you can expand it that way. So that one is condensed form of the CH3. So everything is complete. Carbon have 4 bonds and everything is complete here. So how can we name this? Remember, it is this diagram that I transform to this. Now let's start our numbering forward and backward. So let's say you decide to number your own this way, 1, 2, 3, 4. Straight down like this, the carbon is 4. Let's say another person decide to name his own this way, 1, 2, 3, 4. Another person may decide to name his own this way, 1, 2, 3. So pick all the chain. So you will notice now that the chain can be like this, as in this way, because this is 1, 2, 3. The line that you will not have a break is a chain, or like this, that is 1, 2, 3, 4. Or you have this 1, 2, 3, 4. So anyone you like, you use. So we can see here that the longest carbon continuous chain here is 4. Now that is some people, let me duplicate this so that you will see that there is no cramming here. It depends on how you reason your own naming. So let me duplicate here. So I want to have two namings here. Now let's say you decide to name this way 1 2 3 4, because that is the longest carbon chain 4, and name it backward again 1 2 3 4. So let me move this up. So let's say your friend decides to name his own this way 1 2 3 4. You can't go this way because you have 3 carbons, so we pick the longest continuous carbon chain. That is rule number 1. So let's say your friend decides to name this way 1 2 3 4 instead of this way. You will still arrive at the same result. So forward and backward, always number forward and backward. Now let's start the naming. So consider this one first. The longest carbon there is 4, and that is both. Remember that 4 carbons is both. So now, how many bonds do you have here? We have single bonds. So normal, this is butane. Without this attachment, it should be butane. So now, see that attachment now. After you have located your longest carbon chain, the one that you did not number, that is, you did not consider in the carbon chain, is now attachment. So if you look at that attachment, you will see CH3. It is one short of hydrogen from CH4. Remember, CH4 will be methane because CN. So this is methane, but this is CH3. Anytime you have one short of hydrogen, then is an alkyl group. I've mentioned this in the third video. So that means is an alkyl group. So this is methyl now, one short of hydrogen from methane. So methane is CH4, so methyl will be CH3. Please watch the first video to understand. So this is methyl now, but I have both already, and I have ANA, the surface, because everything I have here is single bond. So this is butane. Now I will not stop because there is an attachment there. What is now the position of this attachment? So the position, we pick the closest position to the attachment. So you see, if we number this way 1 2, the attachment is on 2 carbon. But if we name it backward, if we number backward 1 2 3, the attachment is on 3 carbon. So we pick the closest number, so it's on 2 carbon. That means the name will be 2. First, this is, we have methyl there. That is methyl. We have a methyl group. But what is now the position of that methyl? The position is 2. That is, after 2 carbons, you have the methyl. So that will be 2-methyl butane. That is the name. So 2, the position of this methyl, butane. So, and if your friend decides to number this way, not even straight this way, you will notice that is this one that we did not number, then this is an attachment. The same way, which one is very close to this attachment? Backward, this is 1 2 3. That means the attachment is after 3 carbons, like that way. So name it forward numbering again 1 2. The attachment is on 2 carbons. So you see the name is still the same. That will be 2-methyl butane. Now we have a rule here. You will notice the way I'm writing the number. So anytime you write numbers, between numbers you use comma to separate, and between numbers and letters you use dash, just like what you see here. Between number and letter you use dash, but between two numbers you use comma, or three numbers. So that is another rule now. So let me write that as a rule. So we'll gather all the rules later. So take note now, another rule. Let's call that rule number 2. So as we are moving, we'll be stating the rule. Between numbers, use comma, as in this comma, but between a number and letter, use hyphen, so that dash, just like what you see here. After 2 I have dash before I write number, but if there are two numbers I will use comma, so like this. But if it is one number and letter, then you use dash between number and letter, but nothing will be between letter and letter, so you leave that one. So let's take that as rule number 2. So now let's name another one. Let's say I have something like this. So after this one I'll continue in the next video. Let's say I have something like this. So let me attach a methyl group here, CH3. Let me also attach another one here, CH3. So now what will be the name of this structure? Remember, you can always split the H as in CH3, and you can leave it that way, so in condensed form, so to take not to take space. So now which one is the longest carbon chain here? So to find the longest carbon chain, there are 4 different ways I can find it. This straight chain first, the longest is a continuous carbon chain. So that will be 1, 2, 3, 4. So also this is another chain like this, so you can have different chain. This is also 1, 2, 3, 4. You can still have another chain, 1, 2, 3, 4, as in anything that can form. That one is like this without break, so it's like this. So that is another 4 carbons. So you will notice there is no how you number. This is another 1, 2, 3, 4. There is no how you find your longest chain. It is 4. Then I'll just take this one as my longest continuous carbon chain. You can take any one you like. The other one will be attachments. So now number forward and backward. 1, 2, 3, 4. 1, 2, 3, 4. So now because it is 4 carbons, then I have both. So because it's 4 carbons, I have both. And because everything I have there is single bond, so that will be ANE, that is butane. Now after I've located my butane, then there are 2 attachments here. This methyl, That means I have dimethyl here. Di is di. Now why is it dimethyl? This is one methyl, this is another methyl, so that is dimethyl. And remember, the alkyl group is one short of hydrogen from alkanes. So you know that ethane is C2H8 because you have Cn H2n plus 2. 2 times 2 4. 4 plus 2 6. So ethane is CH6. So if you now have CH5, so you should know this is ethyl, as in it will not be alkyl group, but this one is ethane. So anytime it is one short of hydrogen from alkane, then is alkyl. So this is ethyl. Please take note. So just like what we have here now, we have methyl because this is CH3, while methane is CH4. So that is CH3, methyl. So how many methyl do you have here? I have one, I have two, I have dimethyl. So now, what is now the position of those methyl? That is when these numbers will be useful. So what's the position? We pick the closest number to the methyl group. So if you number forward, this is 1 2. 1 is after 2, is on 2 carbon. Another one will be on 3 carbon. But if you number backward, 1 2, 1 is still on 2, the other one is still on 3. That means either forward or backward. 1 carbon is on 2, the other one is on 3. So that means we say 2 3 between two numbers. Remember, you use comma or 3 numbers, but between number and letter you use dash. Share you see now. So this is 2,3 dimethyl butane. So that's the name of this structure. So 2,3 dimethyl butane. We got but because of 4 carbons, the longest carbon continuous chain, but everything is single bond, so we have ANE, alkane, butane. Now, how many methyl group do you have there? I have 2, that is dimethyl. What is now the position of those methyl? One is on 2 carbon and one is on 3. That is 2,3 dimethyl butane. Now, what if this is what you have and you want to use this to draw a structure? So let's say it is this you have in question. So you want to draw a structure. So now the same way, you will first count, you will see that you have both first. That means I should have 4 carbons. And butane, that means it's an alkane, it will be single bond. Dimethyl, I know I have 2 methyl, but what will be the position? So that is 2 3. So I have to number the carbon 1 2 3 4. That means one methyl is on 2 carbon, another methyl is on 3 carbon. So like that. So the number may not show if you are doing your own, but for a start, so that you can see the number. So if I want to finish it, I may remove number. So now I'll just fill the rest with hydrogen. So this is 2 3 dimethyl butane. So you should go forward and backward, so like that. In another video, so we'll continue with the naming.